Hey there. In chemistry, there's a topic you're going to see over and over and over again because it's used in so many things. It's called molar mass. To find molar mass, it's actually pretty easy. You're going to need a periodic table and a calculator. Molar mass is used quite a bit to find things like pH, molarity, and helping to solve stoichiometric problems. The two skills you're going to see in this video are A, how to find molar mass, and B, how to convert molar mass to grams. Let's head over to the whiteboard and I'll show you how. All right, so how do you find molar mass? Well, thankfully, it's pretty easy. If you can add and subtract and you've got a calculator, you're going to do all right. Molar mass, for this item here, this is a chemical formula for H2S. It has two hydrogens and a sulfur. Now, I've got the equation here that lets you find the molar mass, but where are those numbers coming from? Well, periodic table. Have a look. Hydrogen has a mass of 1. See that little 1.008? That rounds off pretty easily to 1. If we look over on the other side, sulfur has a mass of 32.06. That's pretty close to 32. Have a look at my equation. There's the 1, and there's the 32. Hydrogen has a mass of 1, sulfur has a mass of 32. Now I've also got this multiplier 2 in the equation. Any thoughts where that came from? Looks like there's 2 hydrogen in this equation. You have to multiply the mass of hydrogen by the number of hydrogen you've got present. So if you see little multipliers in here, just realize that's coming from the subscripts in the equation. All right, so you'd add that up. 1 times 2 is 2, plus 32 is 34. That's it. Finding molar mass is not that bad. Now, what is molar mass good for? Well, lots of things in chemistry, but the main one is converting between grams and moles. Depending where you're at in my chemistry course, we may have already talked about what a mole is. Kind of a odd topic there. But if you need to convert from grams, you're going to use molar mass. Suppose you get a question kind of like this. How many moles are in 68 grams of H2S? Well, the way you convert is by taking whatever number of grams you know, divided by the molar mass of that substance. Now, we've just already found that, 34 grams per mole. Okay, so you would take the 68 grams that you know you have, divided by that molar mass quantity. So into the calculator would go 68 divided by 34, and there you get your answer. You get 2 moles of H2S. Hope that helps. That's it. Actually, one more thing. If you see a formula that's got parentheses in it, you need to be careful. In parentheses, when you're in a math class, anything outside the parentheses, like a number, you multiply what's in the parentheses. In chemistry, our subscripts are multipliers. Just like we saw in the previous problem, where you had that little 2 from the hydrogen. Well, we need to do that over here. Here's our equation for finding the molar mass of aluminum sulfate. Aluminum has a mass of 27. Again, periodic table, go look that up. Aluminum has a mass of 27, and there are 2 of them. So I multiply by that 2. All right, sulfur we've seen before. It's got a mass of 32. And I'm multiplying it by 3. Okay, sulfate is one of those groups in chemistry. It's called a polyatomic ion. It tends to travel as a group called SO4, called sulfate. This 3 outside the parentheses is telling me that I've got 3 groups of SO4. Well, every group of SO4 has 1 sulfur, but I have 3 groups. So there's 3 sulfur. So I multiplied the mass of sulfur by 3. Last up, there's a 16 here. 16 is the mass of oxygen. Again, find that from periodic table. But you notice I'm not multiplying it by 4. There was a 4 next to the oxygen. Why is there a 12? Well, I've got 3 groups of 4. 3 times 4 is 12. There's 12 oxygen here. Okay, so it'd be time to calculate all this. There's 12 oxygen because of 4 times 3. There's 3 sulfur, and there's 2 aluminum. So I'd go ahead and add this up. 27 times 2, add that to 32 times 3, and then add that to 16 times 12. Now we get a mass of 342. That's what it would look like if you're plugging it into a TI-84 calculator. 342 grams per mole. Hope that helps. See you in the next one. Adios.